Welcome back, folks, to the Get a Grip on Lighting podcast. In today's show, we have our friend, an old friend, Adam Lilien, Greg, along with Bryan Steverson from the GSA. So we got the Adam from the UL and Bryan from the GSA, and we're talking health effects. Come on, man.
Can't get any better than that.
Oh, that was a mind blower, actually. That podcast, Adam Lillien's told me a couple times, and every time I always leave, Adam in doubts. I don't think I doubt anymore. I think they almost have it all figured. Well, they've almost started to have it all figured out. Does that make sense?
Almost started. Yeah, I would say that's a fair analogy for sure.
You know, so, but before you do that, remember the original and focus. That's right. They're ready to go right now. You don't have to wait. You go to energyfocus.com. That's ENERGYFOCUS.com, Greg.
That's right. And on the topic we talk about today, this is and they put it right there. It says retrofittable and affordable human-centric lighting. Affordable is a key word. You know that their program, their system is the most affordable human-centric lighting there is. I know the word might not be the one you want to use, Mike, the human-centric, but we're going to use it because it's there. And they have 10-stage dimming and color tuning capabilities. And
no, I think this product is human-centric lighting, and that's okay. Because they're not talking about anything else, you know? What they're talking about is a really low cost, high value product that you can retrofit in that can help humans today. That's what they're saying. That's what Adam's going to tell you right now on the podcast from UL, and Bryan is going to tell you. And Focus has a product that can help with that right now. Ehrich.
That's right. Most affordable way out there, easy to do. Type B, bypass the ballast, everything built in. Use your existing fixture. It's easy.
And of course, the National Association of Innovative Lighting Distributors. You go to NAILD.org. I don't have my hat today. You know why I don't have my hat? Because I wear it a lot. Go to nailed.org for right now. Bryan Steverson, Adam Lilien on the Get a Grip on Lighting podcast. Welcome to the Get a Grip on Lighting podcast. Welcome back, Adam Lilien. And also, welcome, Bryan Steverson, for coming on. Thanks for coming on the show.
Thanks for having me.
Hey, Greg.
Glad to be back.
Yeah, it's good to have you back, man. Hey, Greg, we've spoken to Adam a lot of times. And when I said, before we started recording, I said, let's elevate our consciousness. The reason why I said that, because it always seems to happen when we speak to Adam. And that means there's big expectations for you, Bryan. Why don't you fire this thing up, Greg, and get everything going here for the listeners?
Well, why are we talking to both of you? How about that?
Well, I think both UL and GSA are becoming more instrumental in the shift from the pure science of circadian health and lighting and what actually happens in buildings. Bryan, you want to add to that?
Sure. So GSA is just a little bit about who GSA is and what we do. We're one of those agencies that you don't really hear much about, which is good. We're typically out of the news. We're a behind-the-scenes agency. Really, we're there to support other agencies in completing their missions. One of the big things that GSA provides are workspaces for federal employees. So we own, operate, and lease federal buildings. And part of the conversation we've been having at GSA for the past 5 years or so is we know that buildings have a lot of risks involved in them, especially the older buildings with asbestos and mold and lead paints, things like that. But can buildings also be a place that can promote health and well-being for people that work in them? Because we all spend so much time in buildings. Now, this is obviously pre-COVID, but I think for GSA's standpoint, we are really exploring ways that when you're at work for the amount of time that we're all at work, is there a way that we can actually come out on the better end of this from a health perspective? And so that's where the lighting aspect has come into play.
It's a big goal, and it's a moonshot, actually, the way I see it. So what do we know? I've talked to a lot of health experts. Greg and I have, kind of been on the circuit with Adam and going around at different shows before COVID, and then also, speaking to them on a regular basis. What I can say as a light bulb salesman that's definitive right now that I've learned is that, number one, humans are not nocturnal. Okay. So we should be awake during the day and asleep at night. And there's a big difference between sunlight and electric light. And the third thing that, I've asked a couple times, but, are sunglasses bad for you or good for you? And so, is sunscreen bad for you or good for you? Should we actually be blocking the sun's rays when we're outside, or is there something happening that we're getting from the sun that is super important for our health and well-being? So I know those things, and the final kind of caveat that I kind of tack on to that when I'm speaking is that the idea of promoting human health is new, but the ability to hurt people with lighting is very old. And so we've done a lot of harm with flicker. I mean, nobody knows it better than casinos, Adam Lilien, that if you shine 5,000 K vertically directly into someone's eyes, they'll give you their paycheck, right? So we know that, right? We know that we can do these things. Adam, what is it that we can do? Do you have definitive actual product level on the street evidence that we can do things that will actually improve human health outcomes with electric light?
Yes.
Son of a gun.
The good
That
news,
easy. Yes.
the good news is that we've simplified it to more light during the day and less light during the night, and getting it right means easier falling to sleep, deeper sleep, better immune system regeneration, better ability to fight off illnesses, lower cases of depression, diabetes, and even potential for long-term cancer reduction. And that's the science. So that's unequivocal. And I think where the lighting industry, you mentioned a moonshot earlier, I think we have to acknowledge where the lighting industry has been, which is that for over 100 years, we've believed that it's sufficient to just light for tasks, so we can have this conversation. Otherwise, we might all be in the dark. And the science is solid. I think what's really interesting is that with GSA stepping in, and with the pandemic putting a question in all of our minds, what's going to happen to office spaces when we do come back? I think that's a good place to turn the corner on this conversation.
So, Bryan, GSA, what does that stand for?
GSA stands for the General Services Administration.
Okay, and you guys are only dealing with federal offices. Explain again the background of what you guys do.
Yeah, so right, one of the many things that GSA does, in addition to supply schedules, but it's federal office buildings. So courthouses, warehouses, land ports of entry. So when you enter the country, you have to go through different security measures. Typically, a lot of those buildings are GSA owned or managed buildings. We do lease buildings. Actually, about 50% of our inventory is lease space from the private sector as well.
Okay, and you guys are actively upgrading lighting in all of these facilities, or some of them, or how are you deciding what to do, and what are you doing?
So for GSA, the last 6 years or so, we've been working with the Lighting Research Center to really take a look at and gather empirical evidence to see how lighting can impact people's sleep quality at night and their performance during the day, looking at alertness and vitality. We're sort of in that next step now where we're starting to pilot different systems in some of our buildings, looking at ways that we can promote better alertness during the day. We're still sort of in the stages of incorporating what we have learned into our design guidelines as an agency, into our performance specs as an agency. The hope is once we can better get some of these things into what we do on a daily basis, that we can really move out when we do lighting projects and have the other seat at the table, looking at lighting not as just a way to put lumens on a desktop, but also as a way to really help people perform while they're at work.
Now, you mentioned you guys are having the Lighting Research Center do testing for you. How are they? What are the tests? What do they consist of? Are you active with that, or you just know they're doing something?
No, yeah, my office, the Office of Federal High Performance Buildings, which is in one part of GSA, we actually collaborated with them for 5 years. We've done studies both in summer and wintertime, looking at 10 GSA buildings across the country, including a VA medical center up in Vermont, some U.S. embassies overseas, asking people if they're interested to wear a light meter while they're at work, and also take part in several psychological surveys that measure sleep quality, that measure vitality, that measure stress and mood several times a day over a set period of time, whether it's a week or 3 weeks, really just to see how the lighting in their space impacts them. And also really to see what seasonal changes are taking place too, because things are different in the spring than the wintertime. Geography plays a big part of that too, looking at places in Northern Europe that only get 4 hours or 6 hours of daylight a year. How does that impact their sleep, and what would additional lighting in their workspace help to improve that?
So you said, how do they wear a light meter? Out of curiosity.
So it's a light meter that the Lighting Research Center calls a dosimeter, but you put it on a lanyard. It's about the size of I just say half of a cell phone, half of an iPhone. So it's very small, but it just hangs right here, sort of in the middle of your chest, very out of the way. And I took part in 2 of those studies that were in Washington, D.C. Just out of experience, they really weren't cumbersome at all. And it's just a good way to see how much light you're getting throughout the day. Honestly, for me, it was very informative. I don't get a lot of light.
So you were measuring light levels, but not necessarily getting into color temperature?
Correct. Just light levels. Correct.
Okay. And is that something that is going to be considered down the road, or do you guys not even really factor in color temperature in this whole argument?
Well, I think, for us, it really was just how much lighting we were getting. The dosimeter that the Lighting Research Center developed, and they know all the information about that. So I can't really speak too closely to it, but it does measure the amount of circadian effective lighting that somebody would get. So it would incorporate just all spectrum that you're being exposed to throughout the day. So as an agency, we're not necessarily concerned about how much short wavelength or long wavelength light we're getting. Obviously, at night, we want to stay away from the blue light, and we're trying to make people aware of that sort of as an educational effort. GSA provides workspace during the day, but if you go home and you're up at night until midnight looking at your iPhone, this close to your face, you're really going to undo everything that's been done during the day. So for us, we're right now, what we have been doing is really gathering just how much light is somebody exposed to, whether it's from electric light or whether it's from daylighting.
Adam, you were the architect of UL 24480, the design guideline. And I think you started talking to us about it about 1.5 years ago. And what are the fundamental... I remember when the IES came out for dark sky, I actually want to talk to you a little bit about that as well later on in the show. But, they came up with the 5 principles of responsible outdoor lighting, right? Is there something you can break it down for the listeners that... the Lighting Research Center says more light at night during the day and less light during the night, right? This is kind of like some basics to get, because you don't want to get too complicated, right? Is there some basic principles that you can lay out for us that kind of summarize the design guideline?
Yeah, and just to clarify something first, I was a member of the task force that Bryan was also on, that was chaired by Mark Ray of the Lighting Research Center. And the results of the task force, which met for 2 years and voted to publish in December of 2019, broke it down this way: if we can deliver the right amount of light during the day and reduce to a maximum the amount of light during the evening, we'll have these impacts to the human body that the empirical studies prove out. And the minimum threshold that was determined to be effective is termed a circadian stimulus, which is a measurement, circadian stimulus of 0.3 during the day, which is a minimum, and a maximum of 0.1 during the early hours of the evening. And that ties to studies that have shown that by by achieving this, we'll start to offset the impact of being indoors under artificial light, which many of us are during the day, and will result in deeper sleep, faster sleep, going to sleep a little bit early. Really entrainment, which is a synchronization up to the daytime and to the nighttime for where we're living on the planet.
Okay, so I don't know how to ask this the right way. So, is that light vertically coming at you? Is it horizontally coming at you? Is it all of it? Like, how do you have to be experiencing this light in order to maximize the effect?
Well, that's a great question. In fact, it's kind of funny you mentioned experiencing it. We're actually talking about non-visual light here, so it's experienced, but not in the typical five senses that we're used to talking about. So the horizontal vertical issue that you're bringing up is really interesting. So for the past 100 years, we've been designing so that the light that hits the horizontal work plane is evenly lit, and we talk about contrast ratios and minimal lux levels, and there's a ton of ways to look at that. The new way of looking at light is to look at what is hitting the vertical plane of our cornea, such that it hits the ganglion cells that are in the back of our eye, right about here. So it's blocked by the forehead. It's changed by the bridge of the nose, left to right eye, sees a little bit differently. And the science is clear enough that we know that the largest issue is volume. So it's the amount of volume that's hitting the back of our eyes, and less about the horizontal surface. So as long as we continue what we've been doing to take care of the horizontal surface, which we're not going to go away from. I don't think you could change that if you wanted to, but we started to address the vertical plane of the eye, which for overhead lighting straight overhead, I'm not going to get much to the back of the eyeball. I have a forehead; it's coming straight down. It's perhaps the light that's in front of me that's coming towards me that's going to have more effect on that. So when we look at overhead lighting, there's a natural challenge to how much that's going to impact, unless we're doing something like shifting to a pendant, and perhaps an indirect pendant. And I had some challenges when I first started to hear that an indirect pendant was going to be more impactful to our circadian stimulus, until you start to look at the math of how light is delivered from an indirect pendant, where you've got if you're looking at it horizontally, you're doing a cross section, the light is going up towards the ceiling, and then it's reflecting down, and it's that reflection down that's going to start to have a better chance to hit the back of my eyeball. But it might not be enough to just account for overhead lighting. We might start to use wall washes. We might start to take into account the reflectiveness of the wall covering, and we might start to use desk lamps. And Bryan was instrumental in his studies at GSA with desk lamps, and I think that that's one of the areas that we'll start to see some progress in over this next decade, is people using desk lamps. But Bryan, could you comment on what you learned about desk lamps and the ability to localize the impact of circadian stimulus?
Yeah, so one thing that we were noticing throughout our work was that, people are very mobile when they're at work, right? We tend to go to different meetings. We tend to get up to go talk to somebody or use a restroom or whatever. But when we're sitting in one spot, normally it's at our desk, and usually we're facing our computer. So what we were able to do was in-house build some lights that would basically shine right at the person as they're working on their computer. So we placed those, and over time they kind of changed from something that was above your monitor to something that was below, and really were able to show that that tended to really give people a lot of light if they were working in areas that didn't have a lot of daylighting coming in. Electrical lighting was actually really helpful in making sure that, as Adam was saying, that people were receiving a circadian stimulus of at least 0.3 or above. And that's what then correlated with showing people having higher alertness levels, and generally in better moods and sleeping better at night.
Get out of here.
And those questions
I
were
mean, that's
answered
so
by
incredible. Hang on a second. Like, that is so incredible, actually. Like, what the statement
it can be that simple.
Like, the statement you just made is incredible. Like, that could be the greatest discovery in the last 50 years. I don't know, antibiotics and this lights thing. You know what I mean? That's an incredible, incredible statement that you've observed that, and you know that to be a fact. Maybe you need to know more about why. I mean, we need to continue to learn, but that's really, really incredible, Greg Ehrich.
It is, and I guess what I was going to ask is how again do you know that? It's just somebody saying, yeah, I slept 8 hours last night, and I usually sleep 7. It was just a matter of surveying. Is that right?
There was surveying. There was definitely questions that were asking, when did you fall asleep? How long did you take to fall asleep? How many caffeinated drinks did you have, et cetera? But one of the interesting things about the dosimeter, which I was talking about earlier, the light meter, was that at night, people would take it off their chest and actually put it on their wrist. It has an accelerometer in there, and it shows movement. So we could actually figure out if someone would actually put it on their wrist and sleep with it. We could figure out during the night when they were stopping moving, and we could calculate from that stop point to the start point the next day and figure out, what the movement was. So that helped us figure out sleep latency, how long somebody went to bed and how long it took them to fall asleep, and then sleep duration, how long, they stopped moving, and then when they woke up. The surveys themselves really help us figure out, did somebody feel, when they woke up, are they really tired? Did they feel more tired, or did they feel well rested? So you get some of the qualitative responses from the surveys, but then the quantitative information is really very useful and really valuable for us by using the data from the dosimeter.
And then
you mentioned
to that,
oh, go ahead now.
If you add to that the wealth of knowledge that we have scientifically of what's actually happening in the body pharmacologically, I'm going to open up with the idea that light is a pharmacological instance for the human biology, and you start to correlate what's happening to the melatonin expression and suppression, and you do that with light, we now understand what's actually happening with what Bryan was just talking about. And if you expand that core that Bryan was talking about out to the the wealth of knowledge, a lot of that is brought all together in UL's document UL 24480, Design Guideline for Circadian Entrainment with Light for Day Active People, and it starts to bring together a nucleus of understanding so that we can actually start to impact people's lives with how we do lighting. And something as simple as a desk lamp, changing somebody's biology, changing the way changing their health. While it was interesting and important before the pandemic, imagine now how we might see that as a way to strengthen our immune system, so that as we're dealing with the current pandemic, we have some options to consider.
Now, Bryan, you mentioned these desk lamps you built in-house. I need to know more about that. What did it look like? What color was it? What output? Is it dim? Give us a whole breakdown.
Sure. So we built, they were used LED strips. I don't know the output themselves, but we were able to calibrate them to deliver a 0.3 CS. Early on, it was just one single strip that was more or less on one of those theatrical mic stands that would adjust, so we could. They weren't fashionable. It wouldn't be sold in. Maybe somebody that was really into industrial, design or whatever. But they were just fit behind the desk themselves, and it was just a white LED strip. In our later phases of our work, the Lighting Research Center built some additional lights that had 3 LED strips in them, and either they were white or they were blue. Both were calibrated to deliver a 0.3 circadian stimulus. These are the ones that were actually deployed to the embassies over in Northern Europe. And the interesting thing was, especially in Iceland, we were there in December a few years ago, and like I mentioned before, 4 hours of daylight a day. the people there, and I will say the white light was really bright, too bright for me. They were all drawn toward it. They wanted it. They put it in their offices, and it worked for them. The people in the other embassy were more on the bluish light, which was not as intense. It's very user friendly. But those were placed typically below the desk, kind of tilted up, looking at the eye. And then later on, for another phase of the work, these same kind of desk lamps had a light engine in them that were able to make sort of a bluish light in the morning. And then automatically, as the day went on, it would shift down to a reddish light. And that was really just to get a sense of what a dynamic light system would be, how red light in the afternoon would really impact somebody from an alertness standpoint, or from just ensuring that we're not disrupting their circadian rhythm, later in the day.
And you guys have mentioned the circadian stimulus. How do you calculate 0.3 and how do you calibrate 0.3? I assume if you calibrate, it depends on the location. It is on the desk, so break that down for us.
I was just going to say, from a way to do it, an easier way to do it, the Lighting Research Center has published a circadian stimulus calculator. So all you would have to figure out is how much light output there is, what the type of light there is, and then it'll do the math for you. So if you want to get a 0.3 CS, you can kind of reverse engineer that once you have the type of light that you're using, and it'll tell you how much illuminance you would need in order to ensure that you're delivering a 0.3 CS. That's probably the easiest way to do it without using other lighting designer tools that you may or may not have available.
And measuring it where, again, maybe you've kind of answered, but measuring it, like if I do it in front of my desk right now and I want 0.3, is it light meter on the desk? Is it facing my computer? Is it facing, where is it at? How do I get 0.3?
It's actually facing your eye, facing forward, because you're making sure the light's coming at your eyeball. Yeah.
Okay.
Whew. Okay, so we're gonna start another lighting boom. So Adam, I want to ask you, maybe we don't want to go too far down these kinds of roads in 2020, but I have to ask, have you guys noticed that people whose ethnic heritage is from lower latitudes, as opposed to, say, the Sami in Finland, high latitude people, is there a difference in their reaction to this, saying that, hey, people who are accustomed, or maybe their ancestors have lived in very near the equator, where there's a lot more sunlight throughout the year, and those whose ancestors are from, northern Sweden or whatever, would respond differently? Is there any evidence about that different people have different needs?
Absolutely. And fortunately, the expert in that area is Mariana Figuera.
Mm-hmm.
She's been the director of the Lighting Research Center, and you've probably been following the news. She's moving to Mount Sinai right as we speak, and she's published quite a few papers on this. In fact, I can refer you to, if you were to Google Mariana Figuera, and I think it's Figueiro, and her TED Talk. She has a great TED Talk that also addresses this.
Okay. So the answer is yes.
Yes.
Okay. Next point, I kind of want to take it sort of maybe more into to Bryan's world, but also you guys have heard of the 300, right? That acronym, 3%, whatever it is, right? Describing, if you can actually impact human. In the age of pandemic viruses, I think we've inverted that curve. So the most important thing, Bryan, is to get people back into the built environment, right? So forget about the energy savings, forget about the lease costs or the rent or the energy. People aren't in buildings anymore. And do you see this as a conduit to bringing people back into the built space?
Do I see lighting as a conduit?
Yeah.
Yeah, I mean, I think it's definitely one of those things that, getting people back into the buildings is going to be a very interesting question, especially of when that might happen. I think lighting can definitely be a way to show people that being at work is helpful, especially light that's affecting your circadian rhythm. But again, there's just a lot of considerations that need to take place, for all that to happen. I think light is extremely valuable with UVC, and just the germicidal lighting that is being, I think, used more now with cleaning spaces. But I think the biggest question that I see is, we've been moving from individual offices, now to open offices. With that, we've been seeing, more lighting coming into the space, more dynamic lighting systems. Is COVID really going to be something that kind of then reverses that? And instead of open offices where people are exposed to a lot of other people in an area, is it going to be moving back to individual offices? I don't know. And I think that's a question that, GSA is contemplating on, getting people back to work safely, of course, in office buildings, but to do it in a way that, can sort of shelter people from viral interactions, and is open office space really the way to do that? It'll be interesting to see what happens in the end of this year and early 2021 when people start to really move back to commercial office spaces.
Before we move to UVC, which is something I want to ask Adam a little bit about in a second, because I'm on the fence with it from both the surface disinfection. Primarily, I'm on the fence with that. Upper air disinfection seems like a very good idea. But before we get into that, color tuning. I think we missed it, Greg. We haven't talked about color tuning yet with Adam. Is there an impact? You've seen the light? Yeah, so you get enough light this and less at night and you're good to go. But what about the color tuning? Is there a value to someone getting 2200 Kelvin at 7 a.m, say, and then hitting a peak of 65 in the afternoon and then slowly setting that sun, so to speak? Is there value in that, or is that just sizzle?
There's a couple different ways to look at that. One is, what do people like and what's their preference? And do they feel better about it? Let's set that aside for a second. Let's talk more scientifically. Yes, it's more efficient, but no, it's not required. So one of the challenges that we have is that when you look at, for example, LED penetration in indoor spaces, and we look at that just a few years ago, we're all the way up to 8 to 10% penetration of LED in indoor spaces, and we've clearly doubled that. But let's even say we've tripled that. Let's be really liberal and say, okay, 70% of our indoor spaces are still lit with non-LED products. So if we're going to wait until a color tuning control system can deliver what we're talking about, we've got decades to wait, right? So I think it's fundamental to understand that you can deliver circadian stimulus of 0.3 and higher with an old fluorescent system. It's more important. Good news is volume is more important than spectrum. Saying that, when you do the calculation of the circadian stimulus using the free calculator at LRC, you are plugging in the spectral power distribution. And that's that curve that has the oranges and the yellows and the greens and the purples and the reds under it that tell you what volume at what nanometer. Interestingly,
hang on, that's a published document? That's a published document?
They can, in almost all spec sheets for a luminaire, you'll have the opportunity to see the spectral power distribution. So many manufacturers publish it. Many haven't. And in fact, many manufacturers don't know where their spectral power distribution file is. We've been working with a couple of manufacturers who are on the advanced stages and they've collected over 1,400 of their spectral power distributions and have tied them to their luminaires, and they're ready when the industry is asking for them. They'll be ready to supply the spectral power distribution. That is critical, especially because the CCT, a 5,000 Kelvin light, a CCT of 5,000 isn't going to perform the same as another light with 5,000. In fact, there are some 2,700 Kelvin lights that are more effective at delivering a circadian stimulus of 0.3 than a 5,000. And so the spectral power distribution is the combination of all of the nanometers underneath the curve, and that's going to be a major shift in the industry, is connecting the SPDs of our luminaires in order to be able to calculate this easier.
I'm going to go over to Greg, but 1 second before I do. I'm going to push back on the decades you said. I think if we're able to get some momentum into the industry and then through into the general population, that you can actually improve people's quality of sleep. I mean, there's a guy selling millions of pillows. I mean, he's out there going crazy with pillows up in Minnesota. I think his factory's there. And he's talking about improving your sleep. He's selling on sleep. Mattress companies sell on sleep. I mean, and that's all sizzle. That's all sizzle. There's no proof that pillow actually, sorry, my pillow. I mean, I don't have one, but I bought one for friends as a joke. But I mean, like, that's marketing. Okay. So we need to get the marketing caught up here. Like the marketing and the training of nail distributors and contractors, people over at NALMCO and the IES. Then we need to get this training out there so that people can do this. I think it will happen very quickly if it becomes very hardcore. Greg, do you agree with me?
Yeah. If we get to a point, I think it could, for sure.
I love lighting boom.
Let me pose the situation. So I think the work that Bryan and GSA are doing is critical in this part of the conversation. Imagine, whether it's 2021, 22, 23, imagine that they go out with an RFP, a request for proposal, and it's to the industry, and they say, we're going to update this federal building, and it has to hit circadian stimulus of 0.3. And if you don't submit a design proposal that reaches that, justify why you think your proposal should be looked at when it's a requirement. All of a sudden, you've got the manufacturers going, wait, that's a pretty good project. I want to sell my product. You have the lighting design firm saying, how do I know how to deliver this, and what are my plans? You have the distributor saying, geez, what's in my line card that will deliver a 0.3? And all of a sudden, everybody's in the field trying to figure out how to do this. We're getting out ahead of that, and we're offering education. Bryan and I did a lighting, an LEDs magazine, Renaissance of Light webinar about a month ago, I think. And in that webinar, we cover not only what GSA is doing in their field studies and how they've advanced the science, but we also go through very specifically what are the 6 steps in the UL 24480 design guideline process. And we literally put up on the screen step 1, and we have a diagram. We say, this is what you have to do. Step 2, this is what you have to do. Step 3, this is what you have to do. So we're putting out there what needs to happen for the lighting design groups. We're also at the end of that webinar commenting that lighting manufacturers need to be prepared to share their SPDs, their spectral power distributions, and the EV to EH, or the energy vertical to the energy horizontal of their luminaires, because as we know, we've taken care of the horizontal and we need to take care of the vertical. It's the ratio. If I have a downlight that has a distribution that's like this, and I can get my distribution to be more like this, then I'm going to hit the eye better with that ratio. And that type of thinking is what needs to take place. And it's not a very big leap. It's not rocket science. And so in the past, where the lighting industry used to say the science is fuzzy, we don't know enough, we have to become more expert. We don't. We know enough. We can hit this baseline of 0.3 in a circadian stimulus, or the International Well Building Standard has a very similar approach to it. It just happens to use melanops and lux. And because of comments that we received during the open discussion period, we actually changed the task force changed the UL 24480 document to accommodate the well building standard, and the well building standard has updated the requirements, and they now accept the circadian stimulus of 0.3 as a a requirement meeting number in order to hit the well-building circadian requirement. So it's happening.
You mentioned that you can do this with old fluorescent systems. How do you do that? You have to add fixtures? Is that what you do to make sure you hit it, or?
In a way, if you think of the earlier part of when I was talking about, is the light overhead gonna hit my eyeball with my forehead? The easiest way to go into a 1970s classroom is consider the reflectivity of the wall washers, desk lamps. So sometimes the solution will be a little bit non-obvious, but we're talking about, and this is something the lighting designers are they're made for, is layers of light. And if you haven't, I think most classrooms have a white wall anyhow, so you're partway there. But in the hands of a lighting designer, you can look at adding layers of light to achieve the results.
Now, I know I've pushed this maybe too far and continue to ask, but I want to know right now in my office what my CS is. How exactly do I do that? Is that document we got to research through and computerize it, or can I do measurements right here, right now that tell me what I have?
Well, it depends on what you have to measure. One thing that we've been working with is the lighting metrology companies. So there is a light meter that will use my smartphone as the microprocessor, and I can add the light meter to it, and I can now hit a button on that light meter, and I can hold it approximately eye level, and I can look around the room, and as I look towards the window, I might see that I have a CS of 0.5 or 6 or 7. If I look towards the interior of the room and I'm hoping for reflectivity off of walls, I might get a 0.18 or 0.2. Not for you as a consumer is this important, but let's say you were a lighting designer and you're going into a meeting with your customer, and your customer was saying, how, explain this thing to me. How I can make an option. I can give it as an option to the person who's about to lease the product. They can either put a fancier carpet on the floor, or they can get better lighting. But how do we measure this? And the lighting designer pulls out their light meter, and they describe this. They say, as I'm looking at the light here, it's changing, and you're going to hire me. If you do, you're going to hire me to take care of the internal lighting inside the room. And knowing where the desks are, we might actually shift the desks to be facing the window. Whereas in the past, people make their decisions on what they knew before, and glare and other things that we could talk about. But in the hands of the lighting designer, this tool, an inexpensive light meter, it's a $2,000 attachment to a smartphone. Otherwise, it's a $10,000 device if it's got its own microprocessor. So we're also working to figure out how to make this easier for the lighting industry.
What's that thing called? This $2,000, $10,000 item? I'm not going to buy it, but
it happens to be this one I'm talking about in particular is happened to be offered by Ocean. They used to be called Ocean Optics. Now they're called Ocean Insights.
Okay.
And it's the WaveGo. It's the WaveGo light meter. And then interestingly, there's a lot of these WaveGo light meters out in the marketplace. So when they actually roll this out, it'll be a software upgrade. So you can take the exact same device you have, because what it's doing is it's incorporating the math that is available today on the Lighting Research Center free calculator, which, by the way, is open architecture. It's shared publicly. You don't have to go in the future. You won't have to go to the Lighting Research Center website to use it. They're offering this freely to all manufacturers. So light meter companies also play a big role in this.
Yeah, and I'll say, just to tag on to that, because Adam, I learned something today, because I didn't know about that light meter. We've been using a different one from a different company that offers the same kind of metrics. So I think the point is that these measurements, the equivalent monopic lux and circadian stimulus, are fairly new, but these are measures of circadian lighting that are appearing more and more in the marketplace in meters. So being able to measure is becoming more and more accessible, I think, each year.
So I want to ask a little bit about UVC. I want to start with Greg. Can I move on? Can we exchange gears here?
You can move on. I know what to do now. Buy that thing and look around.
Okay, that's by the way, this is incredible and fascinating, and we're just at the beginning. And I love sitting on the nose cone of a rocket before it takes off. Yeah. So the UVC situation. Okay, so NAILD has done a lot of education and work in the UVC, understanding UVC. It's a dangerous technology. Okay, we got to be careful with it. It's what the ozone layer blocks, right? So when people say there's a problem with the ozone layer, they're talking about allowing UVC light from the sun to come to Earth, and it will kill everything. So we have to be careful when it's deployed. And we did some trial lead generation where Greg and I spoke to people, end user customers, about UVC to see, can this actually be a play for lighting distributors, and how can we help, and so on and so forth. And what I discovered is that most people have no idea how this works. They think it's like magic. Okay, when you talk to them, it's like, oh, I put a UVC light and then everything's disinfected. And they confuse the word sanitation and disinfection. They confuse those words. You can sanitize and disinfect with a powerful cleaner, but a light fixture is not going to sanitize anything. It's only going to disinfect a clean surface. So you have these different misunderstandings. To me, Brian, it breaks out into you should in a major building be disinfecting the forced air from your ducts. Like, that's number one thing to do, right? Because those things are filthy. And I have a recycling company, and one of the things we recycle is furnace filters from commercial buildings. Absolutely disgusting. It's hazardous waste, actually. Like, it actually should be classified as hazardous waste. They're not, but it is. The second thing is, so you want to be, a lot of people actually already have UV systems in their furnaces that they forgot to change the bulb for 10 years. Like, they're already deployed in the field. So saying that, I'd say, do you have that? So investigate that first, Mr. Customer, and see if you have UVC lighting in your forced air. The second thing is, I think what we know for sure, Adam and Brian, is that passive upper air disinfection, where the fixtures are reversed and shining on the ceiling above human height, is a very effective in tuberculosis wards. And in places, we've done it since the 70s. They've been using this technology. First of all, is the GSA considering upper air disinfection with UVC as a possible way to bring people back to the space?
Yeah, I mean, this is an area that I know there's lots of discussion on. GSA participates on a lot of different standard bodies that are tackling this issue. National Academies of Sciences is also looking at this. We have UVC really in our forced air, really looking at the coils. But in terms of putting it into buildings, I mean, right now we're really just trying to get our hands around exactly what we need to do to get people in safely, right? I will say that there's, I think ASHRAE's put out several documents looking at UVC, and for upper air, I think that's something that GSA is considering. Unfortunately, I'm sort of away from that aspect of the business, so I can't really say for sure. I do know that people are definitely talking about it. There's been lots of discussion within the federal government from all different types of agencies trying to get clarity on exactly, what we really should be doing for our buildings and our building systems. So I think that's still kind of a question that we're still trying to figure out.
Adam, do you have any thoughts on the order of operations here? Because I'm very leery of surface disinfection in the general environment. We had the situation in China where they blinded the kids with that device that they left on in the room. You have very, very new research about certain nanometer wavelengths that are, I'm doing quotations for the listeners here, that are safe for humans. And we know you're learning how much light impacts our health and wellness. Are we going to be doing it negative here with the surface by shining these nanometers on people? Do you have any thoughts to the order and whether whether surface is actually viable as a mass deployment into office buildings where people that are unaware of it are going to be working or going to school or whatever. And then, of course, some thoughts on passive upper air disinfection, if you have any.
Yeah, let me take a step back for a second and talk about where we've been with COVID-19 and what we've learned. So it wasn't more than a few months ago that I'd very carefully go to the supermarket and select a couple of items that were used up in the last week, and I'd bring them home, and I'd park my car in the driveway, and I'd put these items on the garage floor, and I'd get my 10% solution of bleach, which I learned pretty quickly you can only have the 10% solution of bleach active for 24 hours before it starts to degrade. So I'd go and I'd mix a batch, and I'd spray the stuff down, and I'd wait more than half an hour before I brought it into the house. And that's because that's what we thought was spreading the virus at the time. And we were not wearing masks. And we thought it was a surface to hand to eyes, ears, nose, and mouth type of spread. What we've learned so far is that it seems to be much more that if the four of us were sitting at a restaurant, we're aspirating the virus, and it's floating around the air, and then we're breathing it in, and depending on how much you breathe in determines whether you catch it and how severe it is. So the surface disinfection a few months ago, absolutely. Air disinfection today, absolutely. I presume will still be there in a few months. And then when I look at the breakdown of where we can use UVC indoors, it's the two major distinctions. One distinction, the third distinction, I discount automatically, which is taking a wand and moving it around. It's too dangerous. It's uncontained. UL's published a paper with NEMA and American Lighting Association, and you can find that on the UL website. And it's a warning to consumers: do not go out and buy these devices thinking you're doing yourself a favor. On the other hand, indoors, there's two ways we can look at UVC and the indoor environment. One is inside the air duct, and some experts have said that if the four of us are sitting around in the same space, and we're counting on the air duct and the UVC lights, typically at the coils, to take care of the spread of virus between the four of us, we're already too late. By the time it gets to the intake on the air duct, we've already caught it, or we haven't, or we're being impacted by it. Let's say for the moment, though, that the air duct and reducing the virus and or bacteria or any living organism that might be growing on the wet ducts is definitely going to impact our health. And so that's has always been and will always be a consideration for COVID today. And trying to take care of the air to deactivate a virus that might be in the air 7 feet and above with a louvered UVC device that's either hanging in the center of the room on a pendant or is on a wall, but they have louvers to control the spread of the light, to deactivate the virus and to take care of how the air is flowing amongst the four of us and amongst the table next to us and the table over there. If we're talking to a competent engineering firm that's no doubt these days also working with the manufacturer of the device, because that's where a lot of this resonant knowledge is. We've talked about in previous podcasts, who's in charge of this. It turns out that the manufacturers have to play a very large role. Their PhD scientists are involved in working with perhaps the MEP firm, the engineering firm on the installation, but they're talking about things like airflow. They're talking about amount of irradiance and at what level, and they're talking about the dosage of the UVC light, which is a combination of the energy output. Closer to a UVC lamp, you've got a high output. Further away, you have less. But with the number of air exchanges, if you have 7 air exchanges and the virus keeps on hitting a lesser amount of radiation, it's still going to deactivate.
Yeah, sure.
And then there's a couple of studies that have recently come out that are talking about the dosage in the 2.6 the measurement for effective irradiance is often in microjoules per centimeter squared.
Yeah, or meter squared. I think it's something 0.3 or something per meter squared. I have a catalog out there from the 80s.
Yeah.
Okay, it's from the 80s, and
Exactly.
it gives you all the math on how to do it.
And we've actually known quite a bit about this since the 1930s, when the studies done by Wells and Wells in the Friends Quaker schools in Philadelphia, where they showed a 3 to 5x reduction in the spread of tuberculosis back then.
Mm-hmm.
And there've been papers back and forth that have disputed that and brought it forward and said it was accurate. But we've done a lot more studies now, and we need some more. We need more studies. But one of the things that's not understood so far is when you put one of these devices in a room, how much does it deactivate? Is an 80% deactivation sufficient to start to see
it's impossible to know that, because all the rooms are going to have different air circulation. Like the air is swimming around us. So I'm sitting in this room here, you're sitting in that room. That air is constantly moving and cycling through the room. But the problem with the upper air disinfection, and this is what we've learned, is that you can't prescribe any amount. When you talk to the UVC guys, they talk about water. So you have this much flow of water through this thick of a pipe at this rate with this much UVC, and the water's disinfected 100%. We know that. But the problem with deploying this in the built environment is that Bryan has two rooms may look identical, but they may have totally different airflow dynamics in them. And so the rate of disinfection is going to be lower or higher, or based on the height of the ceiling, the size, how many people are in the space. Is it winter? Is it summer? Is there AC blowing? Is there a window open? There's a whole the what's the word I'm looking for? There's no way to control it in a sense. Now, they know that if you do this with whatever it is, 0.3 per meters cubed, or watts of UVC energy per meter cubed, or whatever the heck it is, will do something. It will do something, but it's not a foolproof idea. But it's certainly, I think, the safest and most effective way to deploy UVC light if people are going to do it, Bryan.
The good news is that the science is starting to resolve around this, especially with the focus and the grants. You think of the study of airflow in a room. We've done that for ages. You think of HVAC engineers, and then you look to where in the world this is really, really well known. You take somebody like Clive Beggs, PhD scientist at Leeds in the UK. He happens to be probably the only one of them in the world. He happens to be a PhD scientist in fluid engineering, and happens to be a PhD scientist in virology. And so he looked at all of the past publications of UV and irradiation and disinfection and deactivation, and he did an analysis of that. Not because it was going to answer a question, but it was going to bring us to a baseline. And so the science is advancing, and if this were a 6-month pandemic, I don't think we would have given it enough time to resolve the answers. I'm afraid that we're going to have plenty of time to resolve the answers, and the science is moving quickly now.
How active is UL in this? Are they taking a stance and saying, you have to do it a certain way, or are you guys not really getting into UVC lighting?
We're very deeply into UVC lighting, and again, we're an independent third party, so we don't pick winners. We're very careful to help advance, as we have for 126 years. Our job is to. But
nobody's bragging about that 126 years. Not bragging at all.
You can certainly find companies that have been doing it longer, but we have since we've been doing it so long, we're pretty set in our ways. We look at science as a way of helping societies advance the evolution and the adoption of new technologies, because they know they're safe and they know that they're valid. So we certainly see ourselves having a role in UVC, but from a very specific point of view as an independent third party.
One more question, and we're coming up on the hour here. I'm sure you guys got people to talk to, but I want to steal, I think probably Adam. So by the time this gets out, NAILD will have signed an agreement with the International Dark Sky Association. Okay. And we're going to be producing education and videos and technical data and all this sort of stuff in order to teach distributors about the 5 principles of responsible outdoor lighting and how to apply them in the field, and then making the ethical case as to why we should do this. Is there a circadian play here, Adam, with it? Are people getting too many, whatever those thingies are? I can't remember what they were, 0.3 or 0.1 from when they drive home in the dark and they're getting hit with that 5,000 K light. They're at the Walmart parking lot. They're just getting smashed with massive amounts of lumens at night. A lot of those wall packs are pointed out right at the eye, right? They're glare bombs. Is there an impact there that we could look to add to that, to the circadian thing, or is it off the table?
If you told me one word answer, I'd say no.
Okay.
But let me go a little bit deeper. I remember being at probably about a year ago, maybe 2 years ago now, at a conference, and I heard from an LRC researcher who, as a result of the AMA published study that said that 5,000 Kelvin LED streetlights are causing cancer in nurses on the second and third shifts, and as a result, many municipalities around the country stopped putting in LED lights for fear of being sued. One of the researchers at LRC asked the question, well, how much light am I able to get from a light that's 30 feet up, a typical street light? And the way she described it is she set up her apparatus almost as if she were standing underneath the light and looking straight up for 2 hours. Now, we're not going to do that as a human being, but you can do that easily enough with measuring equipment. And what I recall, which is anecdotal, of what she was saying is that the staring up at a 5,000 Kelvin streetlight at that distance was not enough to change the melatonin in the body.
Interesting.
So based on that, now there might be other studies that refute that. It's certainly just one point of knowledge, but it put in the back of my mind that no, it's not a concern at this time. But the concept of light pollution and what it does for everything from sea turtles near the shores to I think one of the biggest impacts is that I think we've lost touch of being a speck in the universe.
Yes. Bingo.
I remember.
Yes.
Yeah. I remember
Totally
being
agree.
on Lake Ontario in a sailboat at nighttime on a clear night and just looking up and being unbelievably amazed. I'm getting tingles as I speak about it, and having a sense of the billions of galaxies out there. And I think that this is a time when perhaps we need to return back to that. And I even fantasize about taking a trip to finding a place on the planet that has clear skies, and my wife and I taking a vacation and renting a chaise lounge chair and looking up at the sky again.
Ontario has several dark sky preserves. So you can just come up north for a bit, but we could probably talk. I'm very passionate about dark sky, but what's interesting is that all these billionaires are trying to go to space, right? They want to go to space. I think we need to bring space back to us, and we need to be able to see the stars. And I think look, man, the Great Pyramid of Giza is aligned every 12,500 years to Orion's belt. Every 12,500 years, the Sphinx looks at the Leo astrological, whatever it's called, on a certain day of the year. Like we are just as aligned to the stars as the turtles and the birds and everything else. And to say that we're not is just like talking about the obvious point that, hey, we're not a nocturnal species, right? That's pretty like it's hard for humans to think that way, but we need to start thinking that we are aligned to this, and this stuff does matter. But Bryan Steverson and Adam Lilien. Hey, Adam, always up with you. And Bryan, thank you for sharing about the GSA and what you guys are up to. I really appreciate it.
I think that the work that the GSA is doing is critically instrumental, and I applaud the work that you guys are doing and what you're contributing to our knowledge.
Well, thank you. I appreciate you guys having us on today.
No, it's our pleasure. Bye for now.
Thank you.
It's get focused, buddy. It's time to get focused. What are you going to focus on? You're going to focus on Energy Focus's N-Focus human-centric lighting system. Now, Colligan doesn't like the word human-centric. I don't think it worked as a broad categorical label. But it does work for some applications, Ehrich. And N-Focus is a human-centric, the lowest cost, most affordable human-centric lighting product out there.
That's right. And it's dimmable and color tuning right in the tube, type B, use your existing fixture. And the other part that we don't stress enough with this is that it's low flicker. And that's across the entire dimming range, not just at the high level. As you dim it, it's not flickering. LEDs that dim right now or fluorescents that dim have flicker. Energy Focus said, you know what? In addition to doing all this other stuff it does, it's not going to flicker. Let's get it done right for you.
So go to ENERGYFOCUS.com. We're talking about N-Focus. And guess what, folks? There's an N-Focus switch right on the wall in the studio here. Why do I like it? I like it because people can come to my studio and adjust the lighting to the color temperature they want while they're recording. It's an amazing application. You start to think about the various applications. Hair salons, Greg. I don't like the way my hair looks. Well, let's change the lighting level a little bit. Let's see, because this is actually a different color. This is one color for doing this. What if we change the color of the lighting?
That looks nice now.
Yeah.
Our bald heads are shining.
Oh, baby. Yeah. But so there's different applications that the industry has never really thought of yet. So you got to go to the original, the flicker-free, the Energy Focus, ENERGYFOCUS.com, the National Association of Innovative Lighting Distributors. You know what, man? You got to get associated, Greg.
It's the best organization to be a part of. If you're in the lighting industry, you want to advance and be better, be part of NAILD.
Yeah, man, come on. And, of course, Adam Lilien and Bryan Steverson. What a good time we had with them, Greg.
Always interesting. Great topic.
And for you out there, our colleagues that happen to listen to this podcast, we thank you as well. From the bottom of our hearts, lots of love's going out to you. Get a grip on lighting. I don't really care if you like us or not, but I don't mind. So like us if you like us. See ya.
Written on the rectory wall, there's a sign there for all. You are lost, Lord is there to find you.